We're going to be talking about how we can use the Pythagorean theorem to help us find the missing side of our triangles. When you learned the Pythagorean theorem, you probably learned it as a squared plus b squared equals c squared. And what we're going to be talking about is x, y, and r. And it's the same exact formula, but the reason we're using x, y, and r is because we are working towards this thing called the unit circle. And we're going to be looking at ordered pairs. Every ordered pair is an x and a y, right? So we're using x and y, and then when you're looking at a circle, there's a thing called a radius, which is the distance from the center of the circle to the edge of the circle. And we're also going to be talking about those. So just to kind of help us make more sense out of things, we're going to be using different letters. Okay, now as far as the triangle goes, what we're kind of working towards is that this point right here is going to be a point on the circle. So it's going to be an x and a y coordinate. So if you look at our triangle here, the distance that we're going to the right to get to be even with that point, that's going to be our x distance. And then the distance that you're going up or down to get to that point is going to be your y distance. So when you're given an ordered pair or an x and a y, those are really representations of the length of the side of your triangle. And then the last part, and it's a little bit hard to see without me drawing in the circle, which I will do in a second, is that your hypotenuse, or the diagonal side of our right triangle, is going to be the radius of our circle. And I don't want to get too much into it because we're going to spend a lot of time talking about it later. But basically, your circle is going to look like this. Okay, and then we're going to have triangles on the inside of this circle, and those will be the radius of our circle. So that's where the x, y, and the r are going to fit into our problem here. Now, most of the time what's going to happen is you're going to be given your x and your y value, and you're going to be trying to find the radius. So the Pythagorean theorem isn't solved for anything. So to make our lives a little bit easier, let's go ahead and solve for r. And maybe it'll make our jobs a little bit easier. It'll save us some time. So I'm going to take the original formula, which was x squared plus y squared equals r squared, and I want to solve it for r. I just want it to be already done, so I just plug stuff in, and it's going to take me straight to my answer. Right now I have r squared. In math, the way to undo a square is to take a square root. So I'm going to take the square root of both sides. And I'm going to do two things at once. I'm taking the square root of both sides, and I am going to flip the sides of the equation because I think it looks nicer when the thing that you're solving for is on the left. So if I take the square root of r squared, that just gives me plain r. And then the square root of x squared plus y squared is going to be on the right side. Okay, so anytime that I want to find the value of r, I can plug it into this little new equation that we have. One other thing I want to address before I move on. When we talked about solving quadratics in Unit 5 and a little bit in Unit 6, we always said you had to put a plus or a minus. Every time you take a square root, you put a plus or minus. And I did not do that this time. And the reason is because we are solving for a length. R is a length. I can't have a negative length or a negative distance. So because in the context of this problem, the plus and minus, it doesn't make sense. The plus is the only thing that's a possibility. So that's why I didn't use a plus or minus. All right, so let's move on to example 1 here. So I'm given two sides of a triangle. Anything that is a horizontal distance, so left or right, that's always going to be your x value. Anything that is a vertical distance, up or down, is going to be your y value. And the thing I'm trying to solve for is r. So over here in this top right box, everything I have written in green, I'm going to use that little formula, and I'm going to plug in my x and my y values. So I'm going to say r equals the square root, and then I have x squared and y squared. Now I know you don't see parentheses around x and y, but my advice would be whenever you plug these numbers in, always put in parentheses, because if you have a negative number, it makes a big difference. So rather than having to remember when it's appropriate, just do it all the time. So I'm going to say 7 squared plus 24 squared. And I put parentheses around both of them. So now in your calculators, I'm going to do it step by step. You may want to just, do everything all at once, and that would be fine. So this turns into the square root of 49 plus 625. I'm sorry, not 625. I'm a step ahead of myself. So it turns into the square root of 49 plus 576. When you add 49 and 576, that's where the 625 comes from. And then in your calculator, or maybe you have it memorized, if you take the square root of 625, you just get plain old 25. So 625 is a perfect square. When you take the square root, the radical disappears. So this is it. The hypotenuse of this triangle has a length of 25 units. All right, now let's try example 2. Things look a little more complicated for a couple reasons. Number 1, you have negatives, and number 2, we have a radical. So just some things to be aware of as we go through this. So I'm going to label everything like I did before. So my horizontal distance, that's the negative square root 3, that's my x value. 1 is my y value because that's my vertical distance. And then I'm looking for the radius of my triangle, which is actually the hypotenuse. Okay, so let's plug everything into our new formula. So I'm going to put everything in parentheses. So I have negative square root 3 squared plus 1 squared. Now, we've talked about this multiple times. If you still don't feel comfortable with it, you are always welcome to put it into your calculator. But the negative square root of 3, if I square it, first of all, it's going to turn positive, because if I multiply a negative times a negative, it turns positive. And second, if I multiply two identical radicals, they disappear and it just becomes the number. So in case you're not clear of what I'm saying, if I multiply the negative square root of 3 times the negative square root of 3, which is the same thing as negative square root 3 squared, the two negatives multiply to make my answer positive, and then the square root of 3 times the square root of 3 would be the square root of 9, which is just plain old 3. So what that means is that I'm going to have the square root of 3 plus, and then 1 squared is 1. So what I really have here is the square root of 4, or just 2. So the radius, or the hypotenuse of this right triangle, is just plain old 2. One other thing that I want to mention, and you may have noticed, is that I said that the radius is always going to be a length. It's never going to be negative. That's why we didn't need the plus or minus when we solved in the part that's written in green. So when you find your radius or your hypotenuse, even if your x or your y are negative, your radius, the r that you're solving for, will always be a positive answer. What we're going to be doing in the next problems is we're going to be talking about, we're going to give you an ordered pair. And that ordered pair is going to help us create a triangle that we will then use our Pythagorean theorem to find the missing side. So let me just go through, and I want to show you what these triangles are going to look like in each of the 4 quadrants. So in quadrant 1, if I gave you an ordered pair, and we're not going to use numbers just yet, but just to make things a little bit more concrete, let's say that I give you the point 2, 3. They're both positives, so that means we'd be in the first quadrant. So you'd go 2 right, and then up 3, and you'd have your point right here. Okay, so that's in quadrant 1. That's going to be our xy. So I know it's technically 2, 3, but I'm just going to use general variables for right now. Okay, so what we're going to do now is we're going to create a right triangle. And we're going to do that by adding in 2 segments. The first segment is going to connect the origin, which is right here, to our point. And then the next thing that we're going to do is from our xy, we're going to drop a vertical line that goes straight down to the x-axis. So it's going to look like this. And that's where our right angle comes from. So now I've just created a right triangle. We know 2 things for sure. This x distance is telling you how far you went to the right to get even with your point. So what that means is that down here along the x-axis, that's your x distance. And then similarly, however far we had to go up to get to our point, that's our y distance. So that would be this right here. And then our hypotenuse, remember that we're going to be using the letter r to represent our hypotenuse. So that would be your r right here. Now, when we talk about these triangles, we're always going to be talking about an angle theta. So what I'm going to do here is I'm going to label our angle theta, and I'm going to do this. It's always going to be the angle that's at the origin. That's always what we're going to be talking about. Now, one other thing we're going to have to talk about is Sohcahtoa. So what I want to do is go through all of these triangles first and set them all up, which will be a lot easier as we go through the last three. And then I want to go back and figure out opposite, adjacent, and hypotenuse, and we'll label those. All right, so let's go on to quadrant 2. Quadrant 2 means that if I had an xy, so just some random point over here, my x value would actually have to be negative because we're going to the left, and then my y value would still be positive. So as an example, I could say like -2, 3. So I'd be going left 2 and up 3 to get to my point. We're still going to draw our triangle the same way, so we're going to connect the point to the origin, and then we're going to drop a vertical line to the x-axis, and that makes our right angle. Theta is again always, oops, I thought that was a different color. Theta is always going to be the angle at the origin, and then our x, y, and r are going to be the same. The only difference now is when I write x, because now x is going to the left, I'm going to put -x. So if we have a number that's negative that's going towards the left, we're going to write it as a negative number. My y value is still positive, so I'm going to put that up here. And then my r value will always be positive. It's always going to be we're always going to measure that in a positive way. So if it makes a little more sense, I could even put -xy as my point. That way you know that your x value has to be negative. All right, in quadrant 3, now my point's going to be somewhere down here. So both of my x and y values are going to be negative. So for example, like the point -2, -3. I would have to go left 2 and down 3 to get to my point. So I'm going to connect to the origin, and I'm going to drop a point. Now I'm actually dropping it up, which doesn't make sense. I'm like drawing it up to the x-axis to make my right angle. Theta is still the angle at the origin. My x value is negative, so I'm going to label that top side there -x. My y value is also negative, so I'm going to make that -y. And then, as always, my r is positive. Quadrant 4, same story. We'd have a point over here. Now I'm going to the right, but down to get to my point, so my y value would be negative. We're going to connect to the origin and then also to the x-axis to make our right angle. Theta is the angle at the origin. My x value is now positive. My y value is negative, and then my hypotenuse will always be positive. All right, so the last thing I want to go through and talk about is the three sides that we're going to use for Sohcahtoa. And those three sides are opposite, adjacent, and hypotenuse. But I'm just going to use O for opposite, A for adjacent, and then H for hypotenuse, rather than writing out all of those letters all of those times. And I'm going to do these in orange. Okay, so when we are looking at these triangles, we're doing everything from theta. So when I'm looking at that angle, that's what I want to figure out. What is opposite of that angle? What is adjacent to that angle? And then the hypotenuse will always be the same. So R, I think I said it for everyone, R is always going to be our hypotenuse. So let's go through and we're going to label H where the R is for every single triangle. Okay, so now let's take a look at our angle theta. And I'm going back to quadrant 1. If you look at our angle theta, the side that is across from it or opposite from it is the y. So that's going to be my opposite, and then that leaves x to be my adjacent side. If I look at quadrant 2, if I'm looking at my theta, across from that, my opposite side would again be my y, which leaves x to be my adjacent side. If I'm looking at quadrant 3, here's my angle. If I look across from that, that's my opposite side, that's y again. And then A would be the x. And then, hopefully you're noticing a pattern here. It's the exact same thing. In quadrant 4, across from my theta is my y value, so that's opposite, and then that leaves x to be the adjacent side. So the moral of the story here is that no matter where your triangle is, the side that represents y, so your vertical distance, is always going to be your opposite side. And the side that represents x, or your horizontal distance, will always be your adjacent side. And then the hypotenuse of your triangle is always going to be the hypotenuse of your triangle. So that's across from your right angle. What's typed on this slide is hopefully familiar to you. This is Sohcahtoa that you learned in geometry. You may have even learned it previous to that. But what I want to do is draw a picture, and I'm just going to draw the picture from quadrant 1 of what our triangle looked like. So we had our right triangle that looked like this. Our theta was the angle at the origin, and then we had our x value was our horizontal distance, y was the vertical distance, and then r was the hypotenuse. And then I also want to go through and relabel our sides using O, H, and A. So the R is always the hypotenuse, that's the side across from the right angle. Y was always our opposite side because that's across from theta. And then X is always the adjacent side. So that's how it looked. That's how everything was labeled in all 4 quadrants. It's just that the triangle kind of moved around a little bit. Okay, so like I said, everything that's typed here, especially on the left side, that should definitely be review. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. What I want to do now is write out these same ratios, but using x, y, and r. And this is how we're going to be referring to these ratios from now on. So I know you have Sohcahtoa committed to memory, but now you need to commit a new pattern to memory. So let's take a look here. For sine of theta, I need to do opposite over hypotenuse. But instead of using O and H, I want to use the letters that go with them. So opposite goes with Y, and hypotenuse is R. So the new ratio that we want you to have memorized is that the sine of theta is equal to Y over R. We're going to do cosine the same way. Cosine is adjacent over hypotenuse, so that would be X over R. And then tangent is opposite over adjacent, so that would be Y over X. Okay, so now on the right side, these may be completely new to you. These are called the reciprocal functions. If you remember, the reciprocal just means you take a fraction and flip it. Like if I take the 2/3 and I say, what's the reciprocal? It would be 3 over 2. You just take it and flip it. So the reciprocal functions are what happen if you take the original functions and you flip them. So instead of sine, which is opposite over hypotenuse, this one right here, which is called cosecant, is hypotenuse over opposite. So instead of y over r, it's going to be r over y. And then the next one is called secant, and that one goes with cosine. So cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, so r over x. And then the last one is called cotangent, and that one goes with tangent. So since tangent is opposite over adjacent, cotangent is adjacent over opposite. Okay, so this is what we've been building up to. So it says that the terminal side of angle theta in standard position passes through the point 815. So the first thing I'm going to do is I'm going to just kind of very generally draw the point 815. I know that they're both positive x and y, so it's going to be in the first quadrant. So this is my point 815. And it doesn't matter that it's not exactly to scale, because that doesn't matter. What matters is that our labels are correct. Okay, so now I'm going to make this into a right triangle. So we're going to do this the same way we did when we looked at all 4 quadrants. So I'm going to connect the point to the origin, and then I'm going to drop a vertical line straight down to the x-axis to make a right angle. So now I have created a right triangle. And I know that x and y are 8 and 15. So I know that my x is 8, so that means my horizontal distance I'm going to label as an 8. And then my vertical distance is a 15, so I'm going to label this vertical side of my triangle as a 15. Now what's missing is that we don't know what r equals. I don't know what the hypotenuse length is. So this is where the Pythagorean theorem comes in. So I'm going to use that we took the Pythagorean theorem and we solved it for r, which looked like this. So I'm going to take that formula and I'm going to use it to figure out what r equals. So I would have the square root of 8 squared plus 15 squared. 8 squared plus 15 squared would be 64 plus 225. If you add those together, you get 289, and the square root of 289 is 17. No more square root because 289 is a perfect square. So I'm going to label this as 17 now. All right, so we are all set. The next thing it says is find the values of the 6 trigonometric functions of theta. Now remember that theta is always going to be the angle at the origin. So we are no longer going to be talking about Sohcahtoa. We're going to be talking about y over r, x over r. So I want to do two things before we actually write down answers. The first thing I want to do is go through and label x, y, and r. So remember that r is always the hypotenuse. That one's the easiest to tell apart. And then x is always our horizontal distance. Y is always your vertical distance. So I have my x, y, and r labeled. The next thing I want to do before we do anything with our numbers is just refresh our memory and go through and write down all of our ratios. So for sine, the ratio is y over r. Cosine is x over r. Tangent is y over x. What's really nice about these is you actually only have to remember 3, and then you just have to remember that the reciprocals of them, you just take it and flip it upside down. So instead of y over r for cosecant, it's going to be r over y. Secant is going to be r over x, and cotangent is going to be x over y. So I have all of my ratios written out, and now all I have to do is plug in numbers. So let's take a look at sine. I need y over r. Y is 15, r is 17, so my answer for sine of theta is 15 over 17. Cosine is x over r. X is 8, r is 17. That's my final answer for cosine. Tangent of theta is y over x. Y is 15, x is 8, so that's my final answer. Now again, once you've figured out the first 3, all we have to do is take them and switch them. So we don't even have to look back at the picture. Now I know that cosecant is going to be 17 over 15. Secant will be 17 over 8, and cotangent will be 8 over 15. Before we do our next example, we need to talk about rationalizing the denominator. Rationalizing the denominator is necessary when you have an answer that has a radical on the bottom of your fraction. So like this right here where it says 2 over the square root of 3, that's not an acceptable way to leave your answer. Just like it's not acceptable to leave your answer written as 4 over 6 instead of 2 over 3. So it's kind of like it's just not all the way simplified. So before we do that, I want to remind you that when you multiply two identical square roots, the square root cancels out. So for example, if you multiply the square root of 3 times the square root of 3, that's the same as the square root of 9, but the square root of 9 is just plain 3. So anytime you have two radicals that are identical, the radical goes away. And we're going to use that in order to get our denominator cleared of any radicals. So step 1 would be to take your expression, so 2 over the square root of 3, and we're going to multiply both parts of the fraction, meaning the numerator and denominator, by the radical in the denominator. So I'm going to take this whole thing and I'm going to multiply the top and the bottom so that it matches this radical right here. Step 2 is that we're going to multiply straight across. And the denominator should turn into a whole number. And that's why we chose the radical, so that it cancels itself out. So I'm going to do the work in the top box because there's no point in rewriting it. So if I multiply straight across, 2 times the square root of 3, we can't do anything with it because the 2 is not in a radical and the 3 is. So we just write them next to each other, 2 root 3. And then my denominator, I have the square root of 3 times the square root of 3. So that's this right here. So that just turns into a plain 3. Now step 3, we don't have to do it in this problem. In this problem we are done. That's our final answer. In step 3, it says, if possible, reduce the radical that's left in the numerator. So that would be this, like the square root of 3 right here. If you could do a factor tree, you would have to reduce it. And then you would look at the numbers on the outside of the radical to see if those also reduced. But like I said, in our example, it doesn't. And in most of the problems that we do in this unit, they're not going to be very complicated. But if you were to do something where you had to rationalize the denominator and it was more complicated, that's what you would need to do. Now we have a new ordered pair, and we're going to try to find the values of the 6 trig functions of theta based on that point. So first thing I want to do is I want to plot that point, draw my triangle, and label as much as I can. So the point 1, negative 2, it would be going right 1, down 2. So I'm just going to put it somewhere down here. It doesn't have to be super accurate, but it does have to be in the right quadrant. And now I'm going to draw my triangle. So in order to draw my triangle, first thing I'm going to do is I'm going to connect the point with the x-axis, and I want to make that perpendicular. So perpendicular line here to the x-axis, and then I connect the origin to the point. And that is what creates my angle theta. All right, next thing I want to do is I want to label my sides. So the first thing before I do anything with numbers is I want to label x, y, and r. So my x distance is always horizontal. So that means this is going to be the x of my triangle. My vertical distance is always y, and then the hypotenuse of the triangle is always r. So I now know what everything is labeled, but now I need to know what the numbers are. We already know some of them. We already know x and y, and we know that because we were given this ordered pair. That's my x and y. So I know x is 1, y is negative 2, and now I need to use that variation of the Pythagorean theorem to figure out the value of r. So the formula that we're using is r equals the square root of x squared plus y squared, and I think it's a good idea always to put parentheses around your x and y values. So I am going to plug this in. My x value is 1, my y value is negative 2. 1 squared is 1, negative 2 squared is positive 4. Remember that a negative number squared is always positive. And then 1 plus 4 is 5. So now I know that my r value is the square root of 5. All right, now we can move on to the actual question. Before we plug in any numbers, what I want to go through and do is just label all of my ratios using x, y, and r, because I think that's a really helpful thing to do, especially if you don't have it memorized. Writing it down multiple times is always going to help you to retain that information. All right, so for sine, we are always going to be doing y over r. Cosine is x over r. Tangent is y over x. Really, those are the only 3 you have to have memorized, because now that I have those, all I have to do is take the reciprocal, and it gives me the other 3. So this is r over y, r over x, x over y. The last thing I have to do is plug in my values. So now I'm going to take those green numbers that I had labeled on the triangle, and I'm going to plug them in. So y over r would be negative 2 over square root 5. X over r would be 1 over square root 5. And y over x would be negative 2 over 1, which is just negative 2. And then I'm going to flip everything. So this would be the square root of 5 over negative 2. I'm going to put the negative kind of just out in front, though, instead of with the 2. This would be the square root of 5 over 1, which is just the square root of 5. And then this last one would be 1 over negative 2. Okay? So everything looks great. There's one tiny thing we have to address, and that is the sine and the cosine. So I'm going to put a little star next to those, and the reason we have to pay attention to those is because I have a radical in the denominator. So on the previous slide of this lesson, we reviewed how to rationalize a denominator. And it's not that difficult of a process, it's just kind of like one extra thing you have to do. So to get rid of the radical in the denominator, I have to multiply by that radical. And I have to do it to the numerator and denominator, because really what I'm multiplying by is 1. I'm just going to change the way the number looks. So what I have here is negative 2 root 5 in the numerator, and then the square root of 5 times the square root of 5 is just 5, and so I have successfully gotten rid of the radical in the denominator, and we're done there. I'm going to do the same thing here for cosine. I'm going to multiply by the square root of 5 times over the square root of 5, so I'm going to end up with the square root of 5 over 5. Those were the only 2 that had a radical in the denominator, so everything else can stay how it is.